Welcome to the ESD Essentials video series, which will cover the fundamentals of electrostatic discharge protection. In today's video, we will cover the IEC 61000-4-2 standard and how it relates to ESD protection. This video is the third entry in a 6-part video series. You can find these videos and more at ti.com/ESD. Almost every analog and digital component has a section in their datasheet that shows the device's ESD rating. Oftentimes, circuit designers will mistakenly look at this section and automatically assume that the device has enough ESD protection to survive real-world use. However, this is not necessarily true because it's important to understand what standards are being used to measure the ESD. Here, we'll go over some common ones that you may see in datasheets. The first one is the human body model, or HBM, that simulates a human body discharging onto a grounded device in a controlled factory environment. The corresponding HBM waveform is shown here in green. The HBM standard is designed primarily to evaluate whether the device can survive the manufacturing, shipping, and assembly process, and it doesn't simulate what the device will actually be exposed to in a real-world use case. The second standard is the charged device model, or CDM, that simulates ESD being discharged from a charged device through a grounded material. The corresponding CDM waveform is characterized by a short sub-20 nanosecond pulse that has a relatively high current peak. Like HBM, CDM is only designed to measure the robustness of the device for the manufacturing, shipping, and assembly process. However, our last standard, the IEC 61000-4-2 model, is different from HBM and CDM in that it is designed to measure devices' robustness in real-world applications and is the standard that we should care about when making sure our system is protected against ESD. This waveform is characterized by a sharp and narrow first peak and a broader peak around 30 nanoseconds. The IEC 61000-4-2 standard has 4 levels, with level 4, 8 kV contact strike and 15 kV air gap strike, as the max standard defined level. Devices next to interface connectors should be rated for at least 8 kV, 15 kV IEC. However, if devices are not rated for at least 8 kV, 15 kV IEC, or the application requires a higher level of ESD protection, an additional external ESD protection diode should be added. Thank you for watching. To keep learning about ESD, watch our next video on clamping voltage. For more details on ESD in general, go to ti.com/ESD.